Okay, so today we're going to be doing solving systems of equations by substitution. In the previous video we did solving systems of equations by graphing, but now we're going to move on to substitution. There will be steps listed on how you can follow each question, and let's begin. So for the next few questions, we have steps for 1a through h, and so we set each equation equal to each other because they're both in y equals mx plus b form. We solve for x to find the x coordinate of the point of intersection, and then we substitute the x coordinate of the POI into one of the original equations given, or equations 1 or 2. So what that really means is we're substituting the x coordinate of the POI into the original equations that we were given, and that's so that you can find the y coordinate of the POI by following order of operations, and then we have the therefore statement with the point of intersection. So these for the next few questions are going to be a lot easier than if it was in a different form, and we'll get to those later. But moving on, and let's begin. So, as we said before, we're going to set each equation equal to each other. So I'm going to move So what I did here was I set each equation equal to each other, and then I followed order of operations to isolate x to get x on its own, and then our answer is 1. And then we substitute x equals 1 into equations 1 or 2. So now we have our point of intersection. So our POI is 1, 2. Because we have POI is x, y. Alright, so that was our first substitution question, and let's go over it. So we set each equation equal to each other. So I have equation 1 right here, and then I have equation 2 right here. And then I took this x and I brought it over here, and I took this 1 and I brought it over here. And when we're moving things when we are moving things across the equal sign, it changes the operational sign. So if you notice here, it's negative x, and we moved it over here, it becomes plus x. And if you notice that we moved this positive 1 over to the other side, it became negative 1. And then I was left with 2x equals 2, so I divided 2 on both sides, and then I was left with x equals 1. After that, we have the x coordinate of the POI. So using the x coordinate of the POI, we substituted x equals 1, or the x coordinate of the POI, into the original equations given, aka equations 1 or 2. I chose the easiest one, and then I was left with y equals 2, and then we have both answers, x equals 1 and y equals 2, and then I just use I just inputted that into brackets, and our equation for the our coordinates for the POI is 1, 2. Moving on. So again, we will set each equation equal to each other. So I will do equation 1 equals equation 2. So 2x plus 1 equals negative 2x plus 5. So 2x plus 2x, and then it's 5 minus 1. And then I have 4x equals 4. Divide 4 on both sides. And then we have, so I will use red this time. The 4 and the 4, with 4x divided by 4, it's common on the top and the bottom, so it cancels out. And we are left with x equals 1. And that's the x coordinate of the POI. Moving on, so we substitute the x coordinate of the POI, or in this case, x equals 1, into equations 1 or 2. And then, so I will do y equals 2x plus 1, y equals 2, 1 plus 1, y equals 2 plus 1, y equals 3. And there you go, we have the coordinates of the POI. So if we did POI is x comma y, and then we have the x coordinate of the POI, and then the y coordinate of the POI. And then so we do our therefore statement. We have POI is 1, 3. And we'll circle it. Moving on. So we have 2 equations, and so we have equation 1 equals equation 2, and then we have x plus 5 equals 2x plus 5, and then we have we have x minus 2x, and then 5 minus 5 equals 0, negative x, negative 1, negative 1, dividing both sides by negative 1, and then I will use green. The negative 1 cancels out, but x is 0. So we substitute x equals 0, which is the x coordinate of the POI, or the x coordinate of the point of intersection, into equations that we were originally given 1 or 2. And then I'll do a line. So y equals x plus 5, y equals 0 plus 5, I will use green again, 0 is cancelled out, y equals 5. Alright, so we have POI is 0, 5, and that's our point of intersection. And again, POI is just x, y. We're looking for coordinates. So we're solving for the x coordinate of the POI, and then we're substituting that into one of the original equations given to get the y coordinate of the POI. Moving on. Alright, so we have equation 1 equals equation 2. We have 2x plus 3 equals negative x minus 6. And then we have 2x plus x, and then we have minus 6 minus 3, negative 9, 3x, divide both sides by 3, and we have x equals negative 3. So that's our x coordinate of the POI, or point of intersection. And then we're going to substitute the x coordinate of the point of intersection into the original equations given, so equations 1 or 2. So now we have y equals 2x plus 3, y equals 2 negative 3 plus 3, y equals 2 in brackets negative 3 plus 3, and then we have y, that would be negative 6 plus 3, and then we have y equals negative 3. And then we have our finishing therefore statement. So our point of intersection is negative 3 comma negative 3. I'll give you a minute to write that down. And moving on. So we have equation 1 equals equation 2. And then we have 2x equals negative 2x plus 8. 2x plus 2x equals 8. 4x equals 8. Divide both sides by 4. 4 is common on the top and the bottom, so they cancel out, and x equals 2. And so we have that x coordinate of the point of intersection, and then we substitute x equals 2 into equations 1 or 2. And then we have so y equals negative 2x plus 8. Y equals, then we substitute the 2 into the x. And then y equals 4. So our point of intersection is 2 comma 4. And then we have so equation 1 equals equation 2. And then we have negative 3x plus 5, 3x minus 13, So we have minus 3x, minus 3x, minus 13, minus 5, negative 18, minus 6x, minus 6, minus 6. And then I'll use dark blue because negative 6 was common on the top and the bottom. And then the negatives cancel out, so it's 18 over 6, which is 3. And then we substitute x equals 3 into equations 1 or 2. So we have y equals negative 3x plus 5. We substitute x equals 3. So we have the point of intersection is 3, negative 4. Moving on to G. Equation 1 equals equation 2. So we have 3x plus 1 equals negative 3x plus 1, 11, I mean. So we have 3x plus 3x, 11 minus 1. We got 10, 6x over 6 over 6. Back to blue. Because 6 is common on both the top and the bottom. We divided both sides by 6 to isolate y and get x, isolate x and get x by itself. So that's the x coordinate of the POI. That's the x coordinate of the POI. And then we substitute x equals 5 over 3 into equations 1 or 2. And then we get y equals 3x plus 1, y equals 3, 5 over 3 plus 1. Y equals 15 over 3 plus 1. Y equals 5 plus 1. Y equals 6. That's the y coordinate of POI. So we have POI is x, y, and then our point of intersection is 5 divided by 3, 6. Moving on. So we have equation 1 equals equation 2. Okay, so we have 8 plus 8, and then 2x plus 2x. So we have 4x, 16, divided by 4 on both sides. Because it is common, they cancel out. And then 16 divided by 4 is 4. And then that's our x coordinate of the POI. And then we substitute our answer, x equals 4, into equations 1 or 2. Either or will work. So we have y equals 2x minus 8. Y would be 2, 4 minus 8. And then y would be 8 minus 8. So y would equal 0. And that's the y coordinate of the POI. And then we have our POI, which is just coordinates that we're looking for. So POI is 4, 0. All right. So we are moving on to more difficult questions. And let's begin. So we isolate one equation for variable y, and then we substitute the isolated y equation, we call this equation A, into the equation you did not isolate. Follow order of operations to isolate x and find its value. Then we substitute our answer, the x-coordinate of the POI, into one of the two equations given to find the y-coordinate of the point of intersection, and then we have our therefore statement for the point of intersection. Moving on. Actually, I'll give you a minute to write this down. Alright, moving on. So, we have to do equation, so this would be equation A. We have y equals negative x plus 6, and then we substitute A into equation 2. So we have x minus y equals negative 4. Then we have x minus negative x plus 6 equals negative 4. And then I'll go with blue. Expand out. For that negative in front of that bracketed expression, we have x plus x minus 6. Negative 4 equals negative 4. And then we have 2x equals minus 4 plus 6. 2x equals 2. Divide 2 on both sides. And then we have x equals 1. And that's the x-coordinate of the POI. And then we substitute x equals 1 into the equation that we were originally given, so equations 1 or 2. So we have x plus y equals 6. That's 1 plus y equals 6. Y equals 6 minus 1. Y equals 5. And that is the y coordinate of the POI. And then we have our therefore statement, so POI is 1, 5. And that was our more difficult question, and we solved it. Very good. Again, our point of intersection is 1, 5. Hopefully you're following along and understanding what we're doing. And we are going to move on to the next question shortly. And moving on. So we have equation A, which is 2y equals negative x plus 8 over 2 over 2. Y equals negative 1 over 2x plus 4. And I'll do red, because 2 is common on the top and the bottom, and we divided both sides by 2 to get rid of the 2 and isolate y in itself. Alright, so we're going to substitute our equation here, our isolated variable, because we isolated the variable in equation 2, and we have our isolated equation for the variable of y. We're going to substitute that into equation 1, and that's written there. So we have x minus y equals negative 4, x minus negative 1 over 2x plus 4 equals negative 4. And again, we have to expand this negative 1 into the brackets. So we have x plus half x minus 4 minus 4. Then we have 2 over 2x plus 1 over 2x minus 4 plus 4 equals 0. 3 over 2x times 2 times 2. 3x equals 0. 3 over 3x equals 0. So x equals 0. And now we're going to substitute x equals 0 into equations 1 or 2. So y equals 4. Yeah, and then we will do point of intersection is 0, 4. And then we will label x coordinate of POI, and then we have our y coordinate of POI. There we go. I'm gonna take a drink of my juice here. Moving on. Alright, I'm going to choose equation 2 to isolate. Then equation A. Okay, so we have equation A, which when we isolated y became negative half x plus half. So now we're going to substitute equation A into equation 1 because we chose to isolate equation 2. So I'm going to erase this and it will just be equation 1. So 2x minus y equals 7. 2x minus negative half x plus half equals 7. And then with green, we use this. There's a negative 1 in front, so we expand that negative 1. We expand this into our bracketed expression. So we have 2x plus 1 over 2x minus 1 over 2 equals 7. So our x coordinate of the POI is 3. And then we're going to actually substitute x equals 3 into equation 2. So we have x plus 2y equals 1. 3 plus 2y equals 1. 2y, 1 minus 3. 2y, negative 2. Over 2 over 2. Y equals negative 1. There you go. And then we have our therefore statement. POI is 3 comma negative 1. And we will be moving on. So we have, we're going to isolate equation A. Yep, okay. So that's negative y equals negative x minus 5, negative 1, negative 1. Divide both sides by negative 1 to isolate y. And we have y equals x plus 5. And that's equation A. And then we are going to substitute equation A into equation 2. So we have x minus 3y equals 13, x minus 3, x plus 5 equals 13. We expanded with the coefficient in front. We have negative 2x equals and x equals negative 14. And then I'll use orange again. Because it was common on both the top and the bottom, they cancel out. Alright, and then we have our therefore statement. And that is everything. So, our point of intersection is -14, -9. And then we're moving on to our last question. All right. So, we isolated y within equation 1. And then we're going to substitute equation A into equation 2. I'm going to use a darker toned yellow just so that you can see it better. So we have 2x. So 5 multiplied by 2 is 10, and then 1 multiplied by 3 is 3. That's x. And it's plus 15 equals 7. We have 6 over 3, or 4 over 2. Oh no, it has to be 6 over 3 because we are adding and subtracting fractions, so it has to have a common denominator. So 6 minus 10 would be -4 over 3x. And then we times by 3. So we have the x coordinate of our POI, which is 6. And I will need a new page. So we will substitute x equals 6 into equation 1. So equation 1 is 2x minus 3y equals 9. So we have 2, 6. So we have our y coordinate, which is y equals 1. So I'll give you a minute to write that down and just take a good look at it. And then I'll take you a minute to write this down. And our point of intersection is 6, 1. Alright, so that was everything. I hope you found that helpful. That was solving systems of equations by substitution. And thank you very much, and I'll see you in the next video.